This is a video from the Exam 3 review in my linear algebra class. Let's take a look at problem 4. Find a to the 10th where a is the matrix 1, 0, negative 1, 2. And so what we want to do first is find the eigenvalues of matrix A. Now, to do this, we need to know what lambda I minus A is. Lambda I minus A is the matrix lambda 0, 0, lambda minus the matrix 1, 0, negative 1, 2. And that's equal to the matrix lambda minus 1, 0, 1, lambda minus 2. Set the determinant of lambda I minus A equal to 0. And so therefore lambda minus 1 times lambda minus 2 equals 0. Solving for lambda, we get lambda equals 1 or lambda equals 2. And so what I want to do now is find a corresponding eigenvector for lambda equal 1 and a corresponding eigenvector for lambda equal 2. And so for lambda equal 1, I'm going to take the matrix 0, 0, 1, negative 1 times the column vector AB, and I'm going to set it equal to 0, 0, that column vector. And so what that tells me is that A minus B equals 0, and so therefore A equals B. And so what I'm going to do is I'm going to let B equal 1. Could I have let B equal 1/2? Yes. Could I let B equal 5? Yes. I just need an eigenvector that corresponds to lambda equal 1. So a nice convenient choice for B is B equals 1. Solving for A is 1. And so P1 is the column vector 1, 1, and that's an eigenvector of A corresponding to lambda equal 1. For lambda equal 2, I'm going to take the matrix 1, 0, 1, 0 times the column vector CD, and I'm going to set it equal to the column vector 0, 0. And now from here, C equals 0 and D is free. It's a free variable specifically. And so it can take on any value it would like. And so for convenience, I'm going to let D equal 1. And so P2 is the column vector 0, 1, and that's an eigenvector of A that corresponds to lambda equal 2. Now, remember, to get matrix P, that is comprised of the eigenvectors expressed as columns. So in other words, I'm going to have P1 in the first column, P2 in the second column. So in other words, I'm going to take the entries of those eigenvectors and then write them as columns to form matrix P. So here, my matrix P is the matrix 1, 0, 1, 1. P inverse is equal to the matrix 1, 0, negative 1, 1. Okay? Now, it turns out that A is equal to PD P inverse. Now remember, D is a diagonal matrix whose entries are the eigenvalues of A. And so A is the matrix 1, 0, 1, 1 times the matrix 1, 0, 0, 2 times the matrix 1, 0, negative 1, 1. Now what I'm going to do is raise both sides to the 10th power. And so it turns out that A to the 10th is equal to the matrix 1, 0, 1, 1 times the matrix 1, 0, 0, 2 to the 10th times the matrix 1, 0, negative 1, 1. But this is equal to the matrix 1, 0, 1, 1 times the matrix 1, 0, 0, 2 to the 10th. So when you take a diagonal matrix and raise it to the 10th, you're just taking the entries along the main diagonal and raising them to the 10th. So again, we get 1, 0, 1, 1, that matrix, times 1 to the 10th, the matrix 1 to the 10th, 0, 0, 2 to the 10th, times the matrix 1, 0, negative 1, 1. And so what I'm going to do is multiply the first two matrices. And when I do that, I get the matrix 1, 0, 1, 2 to the 10th times the matrix 1, 0, negative 1, 1. And so therefore a to the 10th is the matrix 1, 0, 1 minus 2 to the 10th, 2 to the 10th. And that'll do it for this video. For the exam 3 review, and we looked at problem 4. Thank you.